Have you ever stared up at the night sky and wondered, what's out there beyond our universe? Well, you're not alone. Today, we're venturing beyond the edge of the cosmos to explore 10 mind-blowing possibilities of what might exist beyond our universe. Buckle up, because this journey is going to be epic. Let's dive in. First up, the Multiverse Theory. Imagine our universe is just one bubble in a vast cosmic bubble bath, each bubble representing a different universe. This theory suggests that there are multiple, maybe even infinite universes coexisting with our own. These are called parallel universes, or alternate realities. Now, what makes each of these universes unique? Well, each one could have different laws of physics. For example, in one universe, gravity might be stronger or weaker. In another, time might flow differently. Some universes might be almost identical to ours, with only minor differences, while others could be radically different, with no resemblance to our universe at all. One exciting aspect of the multiverse theory is the idea of alternate versions of ourselves. In these parallel universes, you might have made different choices, leading to completely different lives. Maybe in one universe, you're a famous musician, and in another, you're an astronaut exploring the stars. Let's talk about parallel universes. Imagine our universe has a twin, or even many twins, running alongside us. These are like mirror images of our own universe, existing in a different dimension or plane. The idea of parallel universes is a cornerstone of the multiverse theory, but it deserves its own spotlight because it introduces the concept of alternate realities. These universes are almost identical to ours, but with slight or even significant differences. One of the most popular explanations for parallel universes comes from quantum mechanics. According to the many worlds interpretation, every time a decision is made, the universe splits into multiple versions, each representing a different outcome. For example, in one universe, you might decide to go left, and in another, you go right. Both possibilities exist simultaneously, but in parallel universes. Next, let's explore the intriguing idea of extra dimensions. As you know, we live in a 3D world with length, width, and height. But what if there are more dimensions out there that we can't see? In physics, dimensions are different ways we can move or measure space. We are familiar with the 3 spatial dimensions plus time, making it 4 dimensions in total. However, some theories suggest there are additional dimensions beyond these 4. These extra dimensions might be compactified or curled up so small that they are undetectable to us. One of the leading theories proposing extra dimensions is string theory. String theory suggests that the fundamental particles we observe are not point-like dots, but tiny, vibrating strings. These strings vibrate in multiple dimensions, up to 10 or 11, according to different versions of the theory. 6 or 7 of these dimensions are compactified and hidden from our perception. Next, let's explore the intriguing concept of the Big Bounce. This idea challenges the traditional view of the Big Bang and suggests that our universe goes through endless cycles of expansion and contraction. The Big Bounce theory posits that the universe didn't begin with a singular, one-time event like the Big Bang. Instead, the universe undergoes a continuous cycle of bounces. According to this theory, the universe expands from a hot, dense state, eventually slows down, contracts, and then bounces back to start expanding again. This cycle repeats indefinitely. Another possibility is bubble universes. Imagine our universe as just one bubble in a vast cosmic bubble bath, with countless other bubbles floating around us. This idea takes the multiverse theory to an entirely new level of imagination and science. Bubble universes, also known as pocket universes, propose that our universe is just one of many in a multiverse. Each bubble represents a separate universe, potentially with its own unique set of physical laws and constants. Let's delve into the intriguing concept of black hole birth. What if black holes aren't just cosmic vacuum cleaners, but gateways to entirely new universes? Black hole birth proposes that inside every black hole lies the potential to spawn a new universe. According to some theories, when matter collapses into a black hole, it doesn't necessarily crush into a singularity. Instead, it might pass through a bridge or a wormhole into another realm altogether, a new universe. In Einstein's theory of general relativity, black holes are regions where gravity is so intense that nothing, not even light, can escape from them. The center of a black hole is believed to be a singularity, a point where space-time curves infinitely. However, some theories suggest that this singularity could connect to another universe. Next, let's explore the intriguing concept of quantum foam. Imagine the very fabric of space-time as a bubbling foam at the smallest scales, constantly fluctuating and teeming with activity. Quantum foam, also known as space-time foam, is a concept derived from quantum mechanics and general relativity. At the quantum level, particles do not have fixed positions or velocities. Instead, they exist in a state of probability, constantly fluctuating in energy and position. This uncertainty applies to the very fabric of space-time itself, leading to the idea of quantum foam. The Planck scale is a tiny scale where the effects of quantum gravity become important. At this scale, space-time is extremely chaotic, with tiny bubbles or wormholes of space-time constantly forming and disappearing. These changes happen so quickly and are so small that when we look at larger scales, space-time appears smooth and continuous. Now, let's explore the mind-bending concept of the holographic principle. Imagine our entire universe as a three-dimensional projection of information stored on a two-dimensional surface. It sounds like science fiction, but it's a serious idea in theoretical physics. The holographic principle suggests that all the information contained within a volume of space can be described by information on the boundary of that space. In simpler terms, our 3D universe could be a hologram projected from a 2D surface, much like a 3D hologram projected from a 2D film. The next is, imagine everything we see, feel, and experience is just part of a highly sophisticated computer simulation. This idea, known as the simulation hypothesis, suggests that our universe might be an artificial creation, like a giant virtual reality. The simulation hypothesis posits that advanced civilizations, possibly far more technologically advanced than ours, could create simulations so detailed and realistic that the inhabitants, us, wouldn't know they're in a simulation. This means our entire universe, including ourselves, could be a complex digital construct. Our own technological progress gives some credence to this theory. As we develop more advanced computers and simulations, like virtual reality and sophisticated video games, it's becoming easier to imagine a future where creating a simulated universe is possible. Finally, let's explore the concept of nothingness. It's one of the most mind-bending ideas. What if beyond our universe, there is simply nothing, no matter, no energy, no space, and no time? Just an endless void. Nothingness, in this context, refers to the complete absence of anything that makes up our known universe. It is the idea that beyond the boundaries of our universe, there might be a state of pure emptiness, devoid of any physical substance or phenomena. Our observable universe is limited by the speed of light and the age of the universe. We can only see objects whose light has had time to reach us since the Big Bang. Beyond this observable horizon, we don't know what exists. Some theories suggest that beyond this horizon, there could be regions of complete nothingness. So, there you have it. 10 fascinating possibilities of what might exist beyond our universe. The truth is, we don't know for sure, but exploring these ideas is what makes science so exciting. If you enjoyed this video, don't forget to like, share, and subscribe.